All right, section 3.3, we're going to talk about multiplication and division of whole numbers. So our goal today is to do the multiplication, and then we'll do the division next time. Sound good? All right, so to start with, we actually need to define what we mean by multiplication. So if we have finite sets A and B, where n of capital A is lowercase a and n of B is capital B, so these are just the number of items in them. As long as n is not 0, then little n times A is A plus A plus A plus A plus A plus A, all these A's, n times. We say that when n equals 0, then 0 times A is 0. And A times B is the number of items in the cross product of A and B. So n of A cross B. And we've seen this before. We did this when we did cross products, that n of A times n of B equals n of A times A cross B. Now, for the most part, this is defining some very specific cases, but for the most part, what this is telling you is that if you repeatedly add something multiple times, that's the same as multiplication, which we talked about when we did geometric sequences. Do you guys remember that? Some of you are still working on redos about geometric sequences right now. So repeated addition is multiplication. Now there are 3 models for multiplication, again, much like when we did subtraction, especially with subtraction, a little bit like addition, but especially with subtraction, where they are uniquely different. So knowing the 3 different models will help you to identify with your students if there's one that they're in particular not getting, so that you can address the issue that they're really not getting. So the first model is a repeated addition model. So this is usually how we think of multiplication anyway. Repeated addition. Giselle takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? So already, I mean, we know that this is 3 times 4. But we're doing it in some sense that this is 3 items here, and then another 3 here, and another 3 here, and another 3 here. Because in time order, that's what we're doing. 3 tests this Friday, 3 tests next Friday, and we keep going, adding 3 more tests every time, and we get 4 tests. The model is about the fact that we're adding something together repeated numbers of times. Okay? Not the concrete description or the answer of what I just wrote down. That's not the model. That's just the way we're solving it. An array model is used for sets. Okay, so sets mean whole object things. Minhyu is baking cookies. He is able to place the dough 3 cookies wide and 6 cookies long on his pan. How many cookies will his pan hold? This is very different than the last problem. The last problem, something was happening repeatedly, right? This is an arrangement of actual objects. So, visually, this has a really nice picture form to what's going on. It says it's 3 cookies wide. Whoops, that's from last time. Let me not make it dotted. Okay, here's 1. More space if I do it down. 2, 3. And it's 6 cookies long. So here's my second set next to it, my third set, so I have 6 wide or 6 long either way, and then the other dimension is 3. So 3 by 6, right? If we were to count them all up, we would recognize that 6 3 times or 3 6 times, however you want to think about it, gives me how many? 18 cookies.
Question.
Yes, ma'am.
On the first one, how did you get 4 tests?
Because I wrote the wrong number down.
Okay.
Oh dear, no wonder you had this funny look on your face. And it should have said 12 exams as well. I didn't write the units either. Thank you, Rebecca. 12 exams, we'll fix that. But you know what, it's going to be super fun when Kaylee and Jessica watch this video, because they're going to be like, they're not going to see it until you say it on the video. They're going to be like, she wrote 4. Why does she write 4? What's going on? So that'll be fun. And now I'm talking about them on the video. So that's even more fun. All right. It is 12 exams, thank you. And this one is 18 cookies. Okay, so there are probably several things. I don't want you to say them out loud, but you should be in your mind thinking of things that are sold or paired or come or put in arrays. There are objects that this makes sense to give a description for. So when you're working in your group and creating an array description problem, a model problem, you should be able to come up with something that's not cookies on a cookie sheet, right? But something else. All right, there's one more model, and this is an area model. This one's actually used for measurement, kind of like we had a subtraction model with measurement. We had an addition model with measurement. So measurement is we're measuring lengths of something, distances. Alexis is planning a garden. I guess it's planning. She has a space that is 5 feet wide and 7 feet long. How much area does she have in which to plant? So we're going to draw what shape? A rectangle. We're going to do our best to draw the rectangle so that it's 5 in one dimension and 7 in the other. And it's probably not going to be perfect, but we're going to be okay with whatever we end up with. Well, it could be worse. That's 7. And that's 5 wide. So I have 5 in one direction and 7 in the other direction. And what is the solution or the answer to this question? Right, 35, and it's square feet written with feet with a square on the feet like that. You can count the boxes, obviously. You're measuring something different here, right? So if we were doing an array that has the same feel to it, we could talk about planting flowers, but planting the flowers would be an array. But the space in which we're planting the flowers, the dirt space itself or the grass space itself, that's actually area. Okay? So, it's your turn. In your groups, you're going to come up with 3 models. One for repeated addition, one for an array, and one for area. Go ahead and finish up that last one that you're working on. I know a couple of groups are still doing that last one. All right, everybody good? Yeah? Okay. We're going to go through and we're going to do 2 models for each one. So every group, 1, 2, 3, 4, 5. So every group gets to give me 1 example and one group gets to give me 2. So what is an example that somebody would like to share for repeated addition for your word problem? Yes, Serena.
Tori eats 3 cookies every day. After 5 days, how many cookies has she eaten?
Enough to get sick, right? Okay. So 3 cookies every day, and after 5 days, how many she eat? And that's repeated addition, right? Yeah, that one fits. Very good. What's another one for repeated addition? Different group. Catherine.
Okay. Winnie the Pooh borrows 2 honey pots from Rabbit every Wednesday. After 5 Wednesdays, how many honey pots has Pooh borrowed?
All right, so our characters from our books, we can come into play on these, right? So we have Winnie the Pooh borrowing pots from Rabbit. I was trying to think, who was it? Well, it could be from Piglet.
Yeah,
It's true. Okay, so from Rabbit, so he's got 2 pots a day for 5 different Wednesdays. All right, fabulous. How about an array model? Somebody want to share their array model with us? Somebody who hasn't spoken. Ellen.
Ashley wants to choose an eyeshadow color from her mom's makeup palette. There are 6 color options wide and 2 options long. How many color options are there?
Excellent. I don't think anybody's ever done an example with
That was
eye
the first thing I
colors.
thought of. I was like,
Fantastic.
eyeshadow.
That's an array. Agreed? You guys have the picture in mind, right? That's an
Yes.
array. Okay, good job. All right, what about one more array? Somebody else have an array one you'd like to share? Rebecca?
Miss Walker is setting up her classroom. She can place her desks 4 desks wide and 6 long. How many desks can she have in her room?
That's a good one, right? Desks in a classroom. How many wide and how many long? We've got desks in a classroom. That's definitely an array. Okay, so I'm going to pause here for an array because I want you guys to put your thinking caps on, whether it's something you wrote or whether you can think of it off the cuff now. What other objects can you think of that are in arrays? Eggs are good. What?
Rings and a jewelry.
Okay, so like a jewelry case, that would work. Uh-huh. How about soda cans? In a 12-pack? You gotta be careful with like the 24 packs because then they double them up and that's three-dimensional. That's not what we're doing. How about toilet paper? What about cans in a pantry? Right? Something like that? Yeah, there's lots of options that would be able to hit at different kids based on their prior experiences and what they would have seen in arrays. And of course, we've got plenty of options like on cookie sheets with cookies and cupcakes and stuff like that, right? And now we're all hungry, aren't we? Okay. How about area? Which was it, Beth, is it your group that hasn't talked? Okay, can you guys, one of you guys share area for your area model for us? Who wants to talk? Okay, thank you, Rayleigh.
Griffin is making a sandbox. He has a space that is 5 feet long and 9 feet wide. How much area is there to play in the sandbox?
Cool. He's got a sandbox. He's got the area of a sandbox. Okay, one other one, just so that we have an even number from each group, or from our models. Somebody else have an area model you don't mind sharing with us? Ellen?
Molly is getting a pool in her backyard that is 8 feet long and 10 feet wide. What area will she have to swim in? Oh, I just realized though that's going to be.
It would be area. It's okay. You
Okay.
could also talk about the volume of the
Yeah.
water, but you didn't ask about that, so
Okay.
you're okay. That's still area. So she's got the area, at least surface area, right, of the swimming pool. Yeah. Okay, very good. All right, so one of the things I was thinking of while you guys were working, and I don't think I've actually said it, so I need to say it to you. So there's two things that you do when you teach mathematics. The first thing is you teach understanding. So what we've been doing in section 3.2 and now in 3.3 is understanding of addition, subtraction. Right now we're doing multiplication and we'll do division. Okay, it's the understanding component. The other thing that you do when you're learning mathematics and you're teaching mathematics is you have to understand how to do things efficiently. Computation, right? The computation part of the addition, subtraction, multiplication, division is in 3.4 and 3.5. So we will get to those because you're probably looking at this and going, okay, but I'm not drawing a picture every single time I need to multiply 5 times 3. And of course you're not. You're definitely not going to do that. But we're working on the understanding component at the moment. We will work on the efficiency and doing it quickly in the next couple sections, okay? All right. This section moves us into whole number properties for multiplication. So all of these properties are properties we've seen before, but we've seen them with, well, most of them we've seen before. There's a couple new ones. We've seen these properties, the ones we have seen, with addition, and we've seen them fail with subtraction. So the first property is closure. For all whole numbers A and B, A times B is a unique whole number. And you know that to be true. Whole number times a whole number is a whole number. Okay, it's a closure property. Now, there was one problem on your group work last time where it gave you a set. The set was 0 and 1. And it asks you, is this set closed under addition? And the answer should have been no, because 1 plus 1 is 2, and 2 is not in the set. But if you took that same set, 0, 1, and you did multiplication, would it be closed? Yes, it would, because 0 times 0, 0 times 1, and 1 times 1 are all in the set. Okay, so closure with multiplication has, different properties a little bit, than the other numbers or than the other systems with the addition or the subtraction. Just because one doesn't work with addition doesn't mean it doesn't work with multiplication and so forth, back and forth. But whole numbers are in fact closed under multiplication. Commutative works as well. A times B equals B times A. You guys know that to be true. 5 times 3 is 3 times 5. And in fact, that's usually how multiplication tables build on themselves when you're learning them for efficiency's sake, memorizing flashcards, things like that. At some point, the kid gets to the 5 facts and they realize they already know half of them because they've already learned 1 times 5 and 2 times 5 and 3 times 5 and 4 times 5, right? They don't have to relearn those again. There's half as many facts to learn when they get halfway through the number, whether it's 0 to, or whether it's 0 to 5 and 6 to 10, or whether they go all the way up to 12. Sometimes they do. They've already learned half of them because they're actually using the commutative property. We have the associative property, and the associative property says that you can switch the order of the parentheses. So A times B in parentheses times C is the same thing as A times the parentheses of A times the parentheses of A. B, C, whatever it says on the slide. That's the one I'm going with. All right? A times B times C. Now we had an additive identity last time. What is the additive identity element? It's 0. And the reason it's the additive identity is because you can add it to the number on either side and you get back the number you started with, right? Multiplication has an identity as well. The multiplication identity element is the number 1. And the reason is because if you take the number 1 and you multiply it on either side, 1 times 5 or 5 times 1, you get back the number 5, or A is on my slide. Okay? It's a multiplicative identity. That's different than the 0 property. The 0 property, so 0 still is important with multiplication. The 0 property is A times 0 is equal to 0 times A, which is equal to 0, not A. Okay, so 0 is not an identity for multiplication, but there is a 0 property for multiplication. And our last property combines multiplication with addition and multiplication with subtraction. It says if we multiply A times the sum or the difference of B plus C or B minus C, it's the same thing as A times B plus or minus A times C. And we like to draw these, arrows that look something like this, or these arcs, right? A times B, and then A times C. And whatever the sign is here matches the sign here. So our last thing we're going to do, and I'd like for you guys to do them by yourself first and then compare inside of your groups, is to identify what property is present in each of the following 6 examples. So write your answers down. I don't want you to go super fast, but this is not something to belabor over, okay? And then compare with the people in your group. What property is being presented? All right, shall we compare notes? Of course we shall. Let's do it. All right, what do you think the first property presented is for part? What is the property presented for part A? 0. That is the 0 property. Very good. I'll just write the word without the word property. This is 0 property. How about the second one? Commutative, because what's actually changing is the order of the 3 times 4, right? What about the third one, C? That is associative, because we've actually changed where the parentheses, or what numbers the parentheses are around. How about D? That is the multiplicative identity, and I'm so glad to hear some of you saying multiplicative. Please, if you didn't write the multiplicative, that word down, do that, because we want to make sure that we're identifying the difference between them, because they are different identity elements. How about E? That is distributive. What distributed over things or through things? The 5, distributive. And F is the most unusual looking one. What property is that? It is also distributive. What distributed? The 1 plus 2. So if you didn't see that one very clearly, what we're trying to see is that the 1 plus 2 distributed to the 3 and to the 4. Okay? Very good.